All right, here is another significance test. An investor with a stock worth several $100,000 sued his broker for the lack of diversification in his portfolio, which led to poor performance. Here's the monthly rates of return for 39 months he invested with a stockbroker. During this time, the S&P averaged a 0.95% growth. Does this investor have enough statistical evidence to show his portfolio grew less than 0.95? Um, so let's take a look at this for a second. Our null hypothesis would be that it grew the same as the national proportion, the national average, so that's 0.95. And the person's claiming that it grew less than that. Now mu is the average percent growth in this portfolio. So what we got to do is we got to check conditions. First off, does the data come from an SRS? No. I should answer that. I should say data does not come from SRS. Data do not come from SRS. And since data is plural, you should say data do not come. I said data does not come, but that's more appropriate, or grammatically correct. So now, now we want to check normality or independence. Now we can't. So independence is kind of tough here because we can't say there's 390 months ever. Uh, these might depend on each other. So in order to do this, we have to assume each month is independent, or it's going to throw off our values. And we don't have any good evidence of independence, and it doesn't really make sense to do the 10 is greater than or less than 10 times little n here. So we'll just have to assume it. And for normality, now there's 39 months. 39 is more than 30. So since n is greater than or equal to 30, we assume, or not, we assume the data is approximately normal by central limit theorem, or central limit theorem tells us data are approximately normal. All right, so we got that out of the way, and now we just have to do the significance test, or the calculations. So in our calculations, we're finding the probability that we got a sample that is less than 0.95. Now, that, or actually, that's not the case. We have to actually find our mean here, not 0.95, because that's our mean. So we plug all these in, you find a value, and the value I got was negative 1.0997. So let's say about negative 1.1. So our z-score will be less than this value, minus our mean of 0.95, all over our standard deviation. Now our standard deviation, we don't know our population standard deviation, so we have to use S. Our S is 5.99. Now when we use 5.99, that means we can't use a Z, we'll have to use a T, because we don't know the population standard deviation. And we're going to divide by the square root of 39. So now that's the probability our t-value is less than or equal to uh, doing the math here, minus 0.95 divided by zero point 0.9. So I got a t-value of negative 2.13. Now, that was our t-test statistic. Now to find that probability, we're going to do a t-CDF from negative infinity all the way up to that value with a standard error or a degree of freedom of 38. And our value is 0.019, so 0.02 is close enough. So now we interpret. Now for the interpretation, p-value is low, so we reject the null hypothesis. Since it's lower than our alpha, we reject the null hypothesis. And then we have to say what this means. So we can say we have evidence that this portfolio performed worse than the general market. So it did much worse than the S&P 500